Hello children, we are doing class 12 chemistry CBSE sample paper 2022-23 section B 2-mark question. That one question number 21, give reason for the following. That one A, during the electrophilic substitution reaction of haloarenes, para substituted derivative is the major product. For that one, the reason is, later we'll do B. So for the A part, reason is, answer for the A part. At the ortho position, higher steric hindrance is the, hence para isomer usually predominate and is obtained in the major amount. So its explanation, we'll do any halogen. I'll do one example for electrophilic substitution reaction. This one is the explanation. Main answer is the first point. So explanation here it is. Electrophilic substitution reaction, we can consider either chlorination, sulfonation, nitration of any halo compound. So I'll take the chlorobenzene actually. So chlorobenzene. Chlorobenzene on nitration. So that means reaction with nitric acid. On reaction with nitric acid. In the presence of concentrated sulfuric acid. Will give para-nitrochlorobenzene as the major product and ortho-nitrochlorobenzene as the minor product. So major is para-nitrochlorobenzene. Or in terms of IUPAC name, 4-nitrochlorobenzene. Other one, ortho-nitrochlorobenzene, minor it is. Is ortho-nitrochlorobenzene. That one's IUPAC name in the same way. You will get 2-nitrochlorobenzene, IUPAC name. Now that one is the minor product only. Now why it is becoming major? So this nitric acid is reacting with concentrated nitric acid actually. Chlorobenzene. Reaction. So due to resonance, the chloride, that halogen molecule, that means halogen atom actually, not molecule, halogen atom, that is chlorine, will become positively charged particle. Chlorine will become positively charged particle due to the resonance actually. When chlorine will become positively charged particle, this incoming nitro group, which is an electrophile, HO, NO, NO2. This NO2 is positively charged, HO is negatively charged. This NO2 will come and attack the HO negative and NO2 positive. This NO2 can come and attack the electron rich. Actually, it will become due to resonance. This ortho and para portion will become electron rich. So, NO2 group, nitro group can come and attack the ortho portion as well as the para portion. But the steric hindrance is greater in the case of ortho portion. Steric hindrance means the force of repulsion between the positively charged nitro group and positively charged chloride ion. So that will be greater in the case of ortho portion when compared to positively charged nitro group, that is the electrophile, and the chlorine in the first portion. So here steric hindrance, here it is more. In this case, steric hindrance will be less. The para portion, repulsion between Cl plus and NO2 plus will be less. Steric hindrance is less. Since the steric hindrance is less between Cl plus and NO2 plus in the para portion, every time the major product will be para-nitrochlorobenzene. Then you can remember that one, maximum separation, minimum repulsion. So here maximum separation is the, so minimum repulsion is the, will result in minimum repulsion. Because of that one, what will happen? We'll get para-nitrochlorobenzene as the major product. So here we heard at the ortho portion, higher steric hindrance is the, you can see higher steric hindrance is at the ortho portion. And hence para isomer is usually predominate and is obtained in the major amount. That is the answer. That is the answer for A. Now B part. The product formed during SN1 reaction is a racemic mixture. So main answer is during the SN1 mechanism, intermediate carbocation formed is sp2 hybridized. Formed is sp2 hybridized and planar in nature. This allows the attack of nucleophile from either side of the plane, resulting in a racemic mixture. Again, I'll explain that one with an example. Now we are considering the case of compound. We are considering the case of 2-bromo, 2-methyl propane. 2-bromo now, 1, 2, 3. This is 2-bromo, 2-methyl propane. In the SN1 reaction, step 1. In the step 1 actually, when the bromine will be removed, at that time a carbocation will be formed. That means the nucleophile Br minus will be removed. From that 2-bromo, 2-methyl propane, when Br minus will be removed, a carbocation will be formed. CS3, CS3, CS3. With a plus sign for carbon and Br will get a minus sign. This carbocation is sp2 hybridized. Since it is sp2 hybridized, it will be directed towards 3 corners of an equilateral triangle, having trigonal planar arrangement. So it is planar actually. Said trigonal planar. Now this carbocation on reaction with a strong nucleophile like OH minus to be attacked by a nucleophile like OH minus. On reaction with strong nucleophile like OH minus. The attack can take place on this planar arrangement either from the top or from the bottom. And it will form a product CS3 thrice COH. So in this case, it is step 2. In this case, the attack can take place trigonal planar arrangement it is. So CS3 group will be the CS3, CS3, now carbocation. So attack can take place from the top or from the bottom. Which one? OH minus will come and attack this planar arrangement either from the top or from the bottom, resulting in equal amount of dextrorotatory and levorotatory compound. So if equal amount of dextrorotatory and levorotatory enantiomers are there, means it will result in optically inactive compound, which is called the racemic mixture. So you wrote, during the SN1 mechanism, intermediate carbocation formed is sp2 hybridized. Intermediate carbocation formed was sp2 hybridized and is planar in nature. Actually, along the plane it will be planar in nature. Then this allows the attack of nucleophile from either side of the plane. That means from the top or from the bottom, this OH minus, which is a nucleophile, can attack that planar structure, resulting in a racemic mixture. So that means it is containing 50% dextrorotatory and 50% levorotatory. That means in this case it will rotate the dextrorotatory will rotate the light in one direction, levorotatory in the opposite direction. So that net effect will get cancelled. So that is the answer.